Here we're just asked to sketch this rational function r of x equals 2x squared plus 7x minus 4 over x squared plus x minus 2. Now the first thing we want to do is find our intercepts. So let's start with the x-intercept. Now when you're looking for the intercept, I do not want you to worry about simplifying. Do not simplify before you find, it's the domain. The domain is the guy that you don't worry about simplifying. For the x-intercept, you would want to simplify before you find the x-intercept. But it turns out that this would not be worthwhile. In this case, we had no way of knowing, but we probably should try. Yeah, we should actually try to simplify this so we can see if we get a simpler version of this to find these x-intercepts and y-intercepts. All right, so if we factored it, it would look like this. It would look like parenthesis 2x minus 1 times x plus 4 for the numerator, and for the denominator we would have x plus 2 times x minus 1. And it turns out that none of the factors cancel. We cannot simplify this given rational function, so we're just going to work with it now that we know we cannot simplify it. Once again, let me reiterate to you when we're supposed to simplify it. Find the domain first, then simplify it and find everything else. Okay, this one doesn't simplify, so let's just use it in its original form. The x-intercept is found by setting y equal to 0 and solving, and we do have our factored form, so it's actually easier to work with a factored form. So we're going to set y equal to 0. 0 equals 2x minus 1 times x plus 4 over x plus 2 times x minus 1. Okay, now we're going to multiply. Better yet, we're going to recognize that a fraction can only equal 0 when the numerator is equal to 0. So 2x minus 1 will be equal to 0, or, union symbol, x plus 4 will be equal to 0. Solve each of these. Here you get x equal positive 1/2. Solve this one, you'll get x equal negative 4. So that implies that we have the x-intercepts 1/2, 0, and 4. I'm sorry, that is a negative 4. Negative 4, 0. Okay, we're going to use those in our graph. Now let's find the y-intercept. Y-intercept is found by letting x equal 0, and I think it would be best to do that in the original form. R of x, that's where you let y, replace it with y. It equals 2 times 0 plus 7 times 0 minus 4, so it's just negative 4 on the top. And then on the bottom we have 0 squared plus 0 minus 2. So y equals positive 2. And that gives us the y-intercept ordered pair 0, positive 2. Next, we're going to find the vertical asymptotes. Now we know these are going to be the zeros of the denominator. In other words, you just set the bottom equal to 0, each of the factors in the bottom in the factored form. Set each of those factors equal to 0 and solve. And be sure to leave your answer in the form of an equation, x equals a number. So we have x plus 2 equals 0, together with x minus 1 equals 0. This gives us x equal negative 2, and this is x equal 1. These are the equations of vertical lines in our graph, and they are our vertical asymptotes. Next, we'll find our horizontal asymptotes. Those are different. We're going to compare the degree of the top and the degree of the bottom. So we have the degree of the top of our given function, the rational function, is equal to 2. It was the second degree numerator, and we're going to compare that to the degree of the bottom of our original problem, and that was, that would be also a second degree function, a polynomial. And together, we compare these two, and they're both second degree, so they have equal degree on the top and bottom. That means that the equation y equals lead of the top, lead coefficient of the top, over lead of the bottom is going to be our horizontal asymptote. So that implies, well, let's see, what was the lead coefficient of the top? Lead coefficient of the top was 2. Lead coefficient of the bottom was 1. So y equal 2. The horizontal line, y equal 2, will be our horizontal asymptote. Let's continue this on the next video.